These are the lab tasks for our experiment 3. If you see the lab report, so first of all we have to design a 2 to 1 mask using fundamental gates, then 1 to 2 demarks again using fundamental gates, and the third task is simplify the following function, this function using kmap, and implement using 8 to 1 mask IC, which is 74151, that is this one. So for the first case, if you simulate this one, I already showed the simulation in how to make the sub-circuit video. So we'll simulate this one and this one. In the beginning, let's see the sub-circuit of this 1 to 2 demarks. As you know that this 1 to 2 demarks has one input, one selection pin, and two outputs, and I connected two output with a different LEDs. So this is yellow LED and this is red LED. So if you go to the child sheet, you can see this is our main circuit. So this is the selection pin, this is the AND gate, and this is our input line, and this is our output line. So if we simulate this one, so for this case, our output will be totally dependent on this input line with this selection pin. So if your selection pin is 0, then this will be connected to this one. So let's check it. So if we make changes in W, so we can see the changes in Y naught, and if we change to 1, then our output will be dependent on totally in this one. So you can see, so now our output is changing according to W if the selection pin is high. So this is very simple. And for lab task 3, if you see the function, so this is our given function. So in min terms 1 3 6 7, and if you implement it using kmap, you have these two groups, and from these two groups we can find this expression, so a bar c or ab. And if you implement this circuit with using only the basic gates, so it will look something like this one. But our task was we have to implement it using 8 to 1 multiplexer. So what we did over here, so if you see the truth table, this is our 74151 IC, which is a 8 to 1 mask, and Y bar is actually the inverted of the output pin. So whenever the case is high, the output logic function is high, we make it the high in those cases. So in here the selection pin will be act as a input ABC, and please remember that for this one, this IC, A is actually the LSB and C is the MSB, but in our problem A is MSB, C is LSB. So I connected A to C and C to A. Now let's check it whether it is working as our truth table or not. So simulate this one and let's check this one, 0 0 1. So make it 0 0 1. So our output Y is working, so Y is high. So in 0 0 0 cases, output is 0. You can see 0 0 0, output is 0. And let's check another one. Let's check 1 1 0. So 1 1 0, then output is high. So actually this is actually this circuit is implemented using only one multiplexer, so it will reduce your complexity and it will reduce the number of gate that is used, because for this case you have to use the AND IC, the OR IC, and again you have to use the invert or NOT IC. But by using only a 8 to 1 mask, we just implemented the whole circuit here. So these are actually the lab tasks, which is very simple. So first, before going to your lab report, you just practice this one first and then goes to the lab report. So in the lab report, you have to design 4 to 1 mask using fundamental gates. In the lab task, we make it 2 to 1 mask, so just you have to implement a 4 to 1 mask, design a 1 to 4 demarks using the fundamental gates, and again you have to simplify this expression using K-map and design that circuit using two 8 to 1 multiplexer. So this is using only one multiplexer. You have to add another multiplexer, and in that case you will have actually 4 inputs A, B, C, D. So you have to combine that one. So this is actually your experiment 3. So if you have any question, you can ask in the live session. Thank you all.